All right, everyone, so here comes another experiment. We are going to make some magnetic rings float. Now, it seems like that's what we do with a lot of magnetic things, that they seem to float in the air. They seem to attract or they seem to repel. And why is that exactly? Why do magnets attract? Why do they repel? Does anybody know? Magnets attract and repel because they have two poles. They have a north pole and they have a south pole. With magnets, opposites attract. So if you put a north pole together with a south pole, they will stick together and they will attract. But if you put two poles that are the same, like a north pole and a north pole, or a south pole and a south pole, well, guess what? They repel. And no matter how much you push them together, they're just not going to stick. You always have to remember, opposites attract. We want the poles to be different. So we want a north pole and a south pole. Not a north pole and a north pole, or a south pole and a south pole. I know it's a little confusing, but the more you learn about magnets, you guys it's going to get easier. Just always remember that opposites attract. That's how we get magnets to stick together, because the poles are different. And they want to stick together because they like being different. But when they're the same, they push each other away because they're like, hey, you're copying me. Go away. And that's why they push each other away. So what we're going to do here is we're going to do a little experiment where we're going to have some floating magnet rings. So these are my magnet rings right here. And I have a red one. I have a green one. I have a yellow one. I have a blue one. I have a orange one. And I have a purple one. So all together, they're dancing and moving towards each other. Crazy. So all together I have 6. And how this is going to work is I'm going to use a little base. And all of this is, it's a cap that has a little styrofoam ring in it it basically looks like a donut. There's a center cut out. So we're going to put that down on the table. And we're going to take an ordinary pencil, not a trick pencil, it's nothing crazy. And we're going to put that in the middle of the base so that it stands up nice and straight. And you might have to play with it a little bit so that it stands up, because when the magnets start pushing and pulling, you don't want your pencil to fall over. So as long as it's in there good, then it's good. So this experiment plays with that idea that opposites attract. And when it's the same, they push each other away. So what we're going to try and figure out is how to get the rings to push each other away. And instead of stacking on top of each other, there is going to be some space in between each of the rings. So we're going to start with the red one. And we're going to put the red one on the pencil, and we're just going to slide it down. And now that's the first one on, so it doesn't matter which way it goes. The next one is the green. So this is when we have to start playing with our magnets and seeing which is the same side and which one is the different side, which is the one that's going to attract and which is the one that's going to push apart. So we'll try this way first. We'll push it on. And it is the side that pushes, because when I put it on, no matter how much I push down, it goes right back up. So that's good. So we have some space right in between there. It's almost like it's floating, and no matter how much I push it down, it's going to stay up. So let's try this yellow one. We'll drop it on. Very good. Is that attracting or is that repelling? Very good. It's repelling because, again, it's pushing up. So far, we're doing pretty good. We have all the right sides. Now let's try the blue one. Let's put it on. Oh, we got another one. Is that attracting or is that repelling? If I smush it together, it pushes apart. So again, we're repelling. All right, let's try this orange one. Oh, we got another repel. Look at this. They must all be the right way. Crazy. That never happens. All right, and let's do the purple one. Another one. So look at that. Now the force of the weight of the magnets kind of pushes them down so that they're all together. And what'll happen though is, because they are pushing each other away, because they're all repelling, because they're the same side pole, the poles are the same on all these magnets. When I let them go, they jump up. So every time I take one away, the next one will move up the pencil. And the yellow one comes. And then the green one. And then the red. Now the red might be stuck because it's in the base, but it's okay. So hopefully, see, look at that. If they were all the same, then they would have all stuck together. Look at that. They're all different poles because opposites attract. The other way, all the poles were the same, so they were pushing each other away. But it is pretty cool how magnets work and how magnets figure out if they're going to attract or if they're going to repel. So that one's stuck, so we're going to turn it back around. Ah, they're all sticking together. Look at that. Let's see this one. Oh, that one attracted. So we'll turn it around. Another repelling. Oh, that one attracted. Let's switch it. Very good. And last one. You think it's going to attract or repel? Let's see. It attracted. So let's turn it over. It repels. We push it down and they pop. So that's pretty cool. So if you have ring magnets at home, this is definitely something you can try. You could probably order these on Amazon or somewhere like that. But if not, don't worry. Hopefully we'll be back in school soon and you guys can try this with me. And it's very simple, just a pencil in the middle of it, and you can have fun with magnets, seeing if they attract or they repel based on their poles. And remember, north and south poles. If they are the same, they repel. And if they are different, they attract. Opposites attract. All right, my friends. So I hope you enjoyed this, and we'll be back soon. See you later.